Hi, this is Geometry, Chapter 1-5. We're exploring angled pairs. So we're going to cover adjacent, vertical, complementary, supplementary angles, an angle bisector, and the linear pair postulate. So we have adjacent angles. You can see in this video that, there it goes, is that the shared side of the two angles is ray AG. So angle EAG is adjacent to angle GAM, and no matter how you move these rays around, they are still next, those two angles are next to each other, adjacent. Now we're going to find the measure of B. So if we know that going all the way around is 360 degrees, let's subtract out this 229. So we're going to get 131 degrees. And now we can set up an algebraic equation. You've got 64 plus B is equal to the remaining number of degrees, 131. So if you subtract the 64 from both sides, B is now 67 degrees. Okay? We're going to find the value of X. So if you have 360 degrees going all the way around, let's subtract out this 236. Which is going to leave us with 124 degrees. So now we can write the expression that the adjacent angle of x minus 6 plus 93, this angle plus that angle, is equal to a whole total of 124 degrees. So if we combine like terms, you're going to get x plus 77 is equal to 124. And when you subtract the 77 from both sides, you get x is 47 degrees. Okay. Vertical angles. Vertical angles are where you have two lines that cross and meet at this point K. And you'll see that as they move around, this is congruent, this angle over here is congruent to that angle. And also, this angle up here is congruent to that angle down there, which I wrote. Okay? Okay, so now we're going to find the value of x. So we have these two pieces of information here. You have 6x plus 1, and then we have the 79. We're going to set them equal to each other because these two angles are congruent. So they're equal in measure. So you subtract the 1 from each side, so we get 6x is equal to 78, and divide both sides by 6, so you get x is 13. Okay. Complementary angles. Those are two angles that add up together to 90 degrees. They don't have to be adjacent like this picture shows, but you can see here with this red notation here is that angle BAC is a right angle. That's 90 degrees. So no matter how you move this ray AD, this angle BAC plus the measure of angle BAD, together they're 90 degrees. So let's do some math. So looking at this image, you can see that 64 plus B is equal to 90 degrees. I know my B's and the 4s are wonderful. So anyway, if you subtract the 34 from both sides, we're going to find out that B is equal to 56 degrees. Okay. Now we've got some algebraic expressions. These two are complementary angles. So 27 added to the expression 2x plus 1 is going to be equal to 90. So we combine like terms. So I've got 2x plus 28 is equal to 90. If you subtract the 28 from both sides, you get 2x is equal to 62, and divide by 2, you get x is 31 degrees. Okay. Yeah. Supplementary angles. Those are two angles that add up to 180 degrees. This angle here, DAC, the measure of that, plus the measure of DAH, or HAD, they're going to together add up to 180 degrees. Now these two angles are adjacent, so therefore they are called a linear pair. Now, not all supplementary angles are linear pairs, but in this case, what's shown in this image, those are definitely a linear pair because they're adjacent. Okay, find the value of x. Well, those two are a linear pair. They add up to 180 degrees. They are supplementary. Right, so if we subtract the 48 from both sides, we're going to get 6x is equal to 132. And if you divide both sides by 6, x is 22. Okay, let me go back. I want to make an image of angles that are, if we have the situation where I'm going to make an angle here, and I'll make another one here. Hold on a second. Okay, I altered the picture. What I wanted to say is that in this case, angles DFC and angle AFB are supplementary, but they are not a linear pair. Because together, the measure of this angle plus the measure of that angle is 180 degrees, but they are not adjacent, so therefore they are not a linear pair. Now let me see if I'm done. No. So here I'm showing a linear pair again. Okay. And here, this is an angle bisector. So here you have AD, this ray, is bisecting this angle BAC. So therefore BAD is congruent to angle DAC. All right, now what if I gave you an angle bisector, that AD is bisecting BAC, and I gave you that the measure of BAD was 2x plus 1. Here, I'll write that, 2x plus 1. And then what if I gave you that the measure of CAD was 4x minus 15? How would we set up that algebraic, those two expressions to be able to solve it? Well, if this is an angle bisector, that means that this angle is congruent to that angle. So therefore, you're going to write that 2x plus 1 is equal to 4x minus 15, and then you solve it. Let's see, we're going to subtract the 2 from each side. You add the 15 to each side, divide by 2, and you get x is 8. Which then, if you substitute that value into there, you can find out the measure of that angle. So you've got 2 times 8 is 16 plus 1, you have 17 degrees. There's no point substituting that 8 into here, unless you want to double check your work, because you know that those two angles are congruent. That has to be 17 degrees as well. Okay, if I gave you this situation where BAC is 40, so going all the way around from, whoops, need a pen, sorry, try that again. If I go all the way around from here to here, that's 40 degrees. And then BAD is going to be 3x minus 1. Now the big question is how do you set up that information in a way algebraically to solve it? Well, if this is an angle bisector, this angle is congruent to that angle, which means down here really is 3x minus 1. So you're going to say that 2 times 3x minus 1 is equal to the 40 degrees, the sum of the two angles. So you can distribute the 2, so you get 6x minus 2 is equal to 40. Add the 2 to both sides. Divide by 6, x is 7. So, and if you want to know the measure of that angle, 3 times 7 is 21 minus the 1. This is 20 degrees for this side, and, for this angle, and also 20 degrees for that angle. And let's see, pause. And I just want to say thank you for watching this segment.